Hello, young math Padawans. It's Mrs. Angel with a quick lesson on point-slope form. So point-slope form is the form of a linear equation that we can use if we are given a point on the line and the slope of the line. The form looks like this. Y minus y1 equals m times the group of x minus x1. And there's two pieces of information here. First of all, the coefficient of the group m is the slope of the line, and the x1 and y1 in this formula or form is the point on the line. So what we're going to do in this really quick video is we're going to practice taking a point and a slope of a line, putting it into point-slope form, and then converting it into slope intercept form, y equals mx plus b, where again, m represents the slope and b is the y-intercept. So grab something to take notes with and let's get started. So in example 1, we're going to create the equation of a line that has a slope of 5 and the point 4, 3. So to start off, we're just going to take our formula for point-slope form, and we're going to fill in the information that we know. The first piece of information that's given to us is the slope of this line is 5. So I'm going to take 5 and substitute it for m in my formula. Okay, the next thing that I'm given about this line is that it has a point 4, 3. Now to make sure that I do this correctly, underneath this point, I'm going to write which one is x and which one is y. In this case, 4 represents the x and 3 represents the y. It's a very common mistake to put 4 and 3 into the formula that way and not where the x and y belong. So I'm going to replace x1, which is the coordinate of my point, with 4. And I'm going to replace y1 with 3. Now at this point, if there were any negatives in our point, which you'll see over in example 2, we would have to do some simplifying. But since it doesn't look like there's any negatives or anything to simplify, our equation is just y minus 3 equals 5 times the group of x minus 4. Now we have an equation of the line, but this isn't a form that we're used to. So the second part of this is let's put this into slope intercept form. Let's solve for y and get y by itself. So the first thing that we're going to do that I can see is distribute on the right side. Let's get rid of these parentheses. That leaves us with y minus 3 equals 5x minus 20. Okay. We're one step closer. Now we just have to isolate y by adding 3 to both sides. And that leaves us with y equals 5x minus 17. Now, if we were to pull open a Desmos graph and graph both of these lines, they would be the exact same line because these are what we call equivalent equations. They represent the same set of solutions. In example 2, we are given that the slope of the line is 1/2 and the point is at -1, -2, 1. So again, we're going to start with our formula for point slope. And let's fill in what we know. We know the slope of this line is 1/2. So in the formula where I see m, I'm going to replace that with the information I know. The slope of the line is 1/2. Next, I'm given the information that the point on this line is at -2, 1. So I'm going to go in and label -2 is my x, 1 is my y. And really, I should be labeling those as x1 and y1. Okay, so let's go ahead and replace x1 with -2. And we're going to replace y1 with 1. So now we're going to simplify, and there actually is something to simplify here because this combination of subtracting a negative is equivalent to adding a positive. So when we go to write out our final equation, we have y minus 1 equals 1/2 times the group of x plus 2. And that is the equation of this line in point-slope form. Now, because we don't use point-slope form often, let's go ahead and convert to slope intercept form. Start off by distributing 1/2 to both. So that's y minus 1 equals 1/2 x plus 1/2 of 1 is 1. Add 1 to both sides to isolate y, and we're left with y equals 1/2 x plus 2. And again, if you were to graph both of these lines, they would be the exact same set of points because they are equivalent equations. So now you're going to do a little bit of practice on Desmos with point slope form and slope intercept form. Welcome back, Math Padawans. Now that you've had a chance to practice with point slope, let's actually use it. So here we are given line AB and point C, and we're asked to determine the equation of the line that contains point C and is parallel to line AB. So let's take a look at what we're really given here. In addition to being given the graph of line AB and point C, we're also given the equation of line AB as y equals 1/2 x minus 3. We're given the coordinates of A and B, and we're given the coordinates of C. So let's think for a moment. What is it that we need to know about a line in order to find the equation of that line? Well, there's two pieces of information that we really need to know. First of all, we need to know the slope of that line, and we need to know at least one point on that line, okay? So if we think about what we're really given, we are given a point, but do we know, or are we specifically given the slope of this line? Not specifically. However, we are given that the line is parallel to line AB. So that brings us to our first question. What do we know about parallel lines and their slopes? Well, we know from our exploration yesterday that parallel lines have the same slope because they are rising and running at the same rate, but they are never getting closer together, even as they move on to infinity. Okay, so what does that tell us about our new line that's going to contain C? Well, if this line containing C is parallel to line AB, that means it has the same slope of line AB. So if line AB has a slope of 1/2, which it appears that it does, here's our slope of line AB. What is the slope of our parallel line that contains C? It's also going to be 1/2. So now that I know the slope of this parallel line is 1/2 and the point is 0,3, wait a minute, the point that I'm given is not just any point. I'm also given, this is the y-intercept of the point. So that means I can take this information and put it straight into slope intercept form. I know the slope of my line is 1/2, and I know that the y-intercept of my line is 3. I'm going to go ahead and change this color to blue, and there you have it. I have a line that is going through point C that is parallel to line AB. And I have the equation of that line in slope intercept form. Now let's find a point D to put on that line so that we can name it, because if you want to name a line, you have to have a point. So as I'm moving along here, I can just kind of drag along, and it looks like there's a point at 2, 4. So I'm going to go ahead and label point 2, 4, and label that point D. Now, this doesn't have to be the coordinates of D. We just want to label any other point on this line, so now it has a name. And I'm going to go ahead and change that color to blue. All right, so what do we know? We are easily able to determine the equation of line CD because we were given the y-intercept of the line. But what happens if the point that we're given is not the y-intercept of the line? And that brings us to our next slide. So here in teaching slide 2, we're given some similar information. We're given line ES and we're given point G, but this time the coordinates of G are not the coordinates of the y-intercept, meaning we don't know what that y-intercept is. So here's what we do know, okay? We know that parallel lines have the same slope. So what is our slope going to be of this parallel line going through point G? To answer that question, we need to know the slope of this line. And since the equation of this line is -1/2 x minus 3, that means that this line has a slope of -1/2. And we can also see that in the graph that we're going down 1 and right 2. That means that the slope of the line parallel to line ES is also -1/2. So now let's think about what we know about this mystery parallel line. we know that the slope of this line is -1/2, and we know that the point on this line is 5, 2. So if we're given the slope and we're given a point, we can use point-slope form to put this into an equation. So let's go ahead and do that. So I'm going to start by substituting in my slope, which is -1/2, okay? And then for x1, I'm going to substitute in 5 because that is the x value of point G. And for y1, I'm going to substitute in 2 because that is the y value of point G. And a line has formed. I'm going to go ahead and mark that line using blue. Now, as I zoom in and out here, it does appear that I did find the line that goes through point G that is parallel to line EF. However, we don't use point-slope form often enough to leave our answer in that form. So on your paper, go ahead and convert our point-slope form into slope-intercept form. Okay, so after distributing the -1/2 and adding 2 to both sides, you should have y equals -1/2x plus 4.5 or 4.5. Let's see what happens when I put that into my Desmos. It's the exact same line. I'm going to go ahead and make this purple. So if I highlight only the purple line, you can see that this equation, this line, -1/2x plus 4.5, is the equation of the line that contains point G and is parallel to line EF. It happens to be the exact same line as the point-slope form, just further proving that these are the equivalent equations that represent the same line. So to name this mystery parallel line, let's identify a point H. And point H can pretty much be anywhere. I'm going to make point H the y-intercept because that's the easiest one for me to find because I already did all of the math to get it into slope-intercept form. All right, so what did we learn here? When you are unable to determine the y-intercept, you can use point-slope form to determine the equation and then convert it into slope-intercept form from there. And that's why point-slope form exists. That's it for today's lesson on point-slope. I will see you next time.